Hi there, welcome to this lecture. Now we're going to get into a concept known as thread pools. And this is probably the most practical and useful way of working with threads in the real world. Okay, we spoke about a lot of other multi-threaded concepts in the previous lectures, but this is the most important, and you should know how to use thread pools to create a multi-threaded application. So what's a thread pool? Well, a thread pool is exactly what it sounds like. It's a container of threads. It's a pool of threads that are managed, okay? And you don't get involved with creating these threads. These threads are basically created by this service known as the Executor service. And that service is the thing that manages starting these threads. So far, when you were learning about multi-threading and I showed you how to create a thread and invoke the start method on that thread, you don't have to do that using the Executor service. The Executor service creates a pool of threads, all right? And you can define the size of that pool. So you can say, hey, there's 5 threads in this pool and there's going to be 10 threads in that pool and so on. And that pool is going to be launching those threads, okay? And all you have to do is you just submit your work that needs to get done. You submit that to the pool of threads, and then the pool will take care of whatever the work is that needs to get done. You don't get involved with saying, okay, this thread is going to work on this task and this thread is going to work on this task. You don't worry about that at all. You just submit your work to the pool, and the pool will take care of the work that needs to get done. So it's another way of separating the work that needs to get done from the orchestration of how that work needs to get done. It's a separation, similar to the producer-consumer pattern that I spoke about in the previous lecture. That was another pattern, right? That was basically a way to separate work that needs to get done from the actual way that it gets done. So this is another approach. This is a pool that you give work to, and the pool takes care of whatever the work is that needs to be completed. So let's go over an example. I'm going to create a new package here. Go to New, Package, and we're going to use the same naming convention. We could do com.jobready, which is a company name, followed by whatever the thing is that we're going to be working on. So in this case, it's going to be thread pools. And just hit finish. And now I'm going to right click and go to New, Class, and we'll create a class called Message Processor. So we're going to use a similar kind of example that we used for that question answer example that we were going over. This, you can think of it as a message processor where messages come in and it is able to respond to those messages or whatever. So you could think of this as very similar to the question answer type stuff that we had previously. Now, the kind of messages that this message processor will work on, it's logical to think that they're going to be strings, questions or messages. You can think of these as text messages or email messages. For this example, I'm going to keep things simple, and rather than coming up with sentences on my own, I'm just going to treat this as integers. So what we can do is we'll define a variable called message. Okay, and it's going to be of type int, and since it's not going to be involved anywhere else, I'm going to, of course, make this private. It's a member variable of this class. And so I'll have a constructor, and we'll call it, it's going to be message processor, of course. And we pass in to this constructor the particular message, which, of course, is just going to be an integer. And so the message that belongs to the instance is going to be assigned the message that was passed into the constructor, just like that. And now what I'm going to do is make this guy implement runnable. So you could think of this as a task, all right? It's a runnable task. So we, of course, need to implement the run method in the runnable interface. So I'm just going to hover my mouse over here and just click on Add Unimplemented Methods. And this is where we're going to be doing some message processing, so to speak. So we'll just, keep things simple, and I'm going to print to the screen the current thread and get its name, right? I showed you how to do this a couple of lessons ago, if I'm not mistaken. And then we append to it the following text. We could say received message, and then append to it the actual message that was received, which is of course going to be a number. We can have a method here called respond to message. All right, and this could just be additional processing. For example, downloading questions or answers from the internet and processing those messages in some way, saving them in a database, whatever. Those details, we're not going to get into those details because we're covering this topic, but we're going to have a much more elaborate example later on when I talk about databases, and you're going to actually work on a multi-threaded application that involves working with a database and dealing with lots of data and lots of threads. So that's going to be far more practical than what we're doing here, but this is just a simple example to get you to understand what thread pools are. So, we'll just keep this simple and say respond to message basically is going to just, make the thread sleep. Okay, make the thread sleep to simulate doing some work. Okay. And so after that work is completed, after the message is responded to, I'm going to print the thread's name again, .get name, and then I'm going to append to it the following. We could say that we are done responding to that message, and then I could just say processing message. So it's done processing the particular message, and I'm going to append to it the actual message. So that's going to be the same number. Okay. So let's implement this respond to message. So let's click on the suggestion there, and it creates the body of that. And like I said, this is just going to be, simulation of doing some kind of useful work. So for that, we could just say we're going to sleep for 3,000 milliseconds or whatever, and that's going to sleep for 3 seconds. Now this throws an interrupted exception, so I need to surround this with a try and catch. And if there's an exception in the catch block, I could just print out that, unable to process message. And of course, we're going to append the particular message that we were trying to process or whatever. And that's it. That completes this particular task. So you've already seen work like this, right? We've already talked about the runnable interface. And so I want you to think of this as a task that can be runnable. And we're going to treat this as a particular task that can be run by multiple threads working on multiple messages. So I'm going to create a new class here. Right click, go to new class. And this class is going to be thread pool demo. And in here, I'm going to show you how to create the thread pool using something called an executor service. So this is going to contain our main method. I'm going to select that option, hit finish. And so in here, we're going to need something called executor service. And the executor service is the thing that manages the thread pool. Okay, so I'm just going to define that here, executor service. And we'll just call it executor is equal to this factory method that comes from the executors class called new fixed thread pool. Okay, and we give it the number of threads that this pool is going to manage. So we could say you're going to be using 2 threads to get the work done. All right, we don't tell it which thread is going to work on what. We're just going to tell it, hey, here's the tasks, and you've got 2 threads in you. Spawn them when you need to, start them, get the work done. I don't care, but you're allowed to use 2 threads in the pool. That's what this guy is. So we're not involved with the lower level details of starting those threads and telling them, submitting work to that particular thread. We don't do that. The pool takes care of that. And so this pool comes from this executors class. Let's go into that class definition, and you'll notice that there are different kinds of pools. There's this new fixed thread pool. That's the one that I'm using. And notice that it accepts the number of threads that we are allowing this service to work with to get the job done. All right. And then there's other kinds of pools. There's the new work stealing pool, and there's various others. Let's scroll down so we can go over some of this. New fixed thread pool with a different set of arguments. Then there's new cached thread pool. We don't need to go over all of these details. New single thread scheduled executor. You can look up all of these methods separately, but one of the most common ones is what I have here. New fixed sized thread pool. So we give it the number of threads that this pool is going to manage, and those are the number of threads that it'll use to get whatever work done. Okay, now this executor service, I need to import this class. Hover your mouse and notice it comes from the java.util.concurrent package. So click that and notice it brought in the executors as well as the executor service. So this executor service is the thing that manages the thread pool. So we've assigned it a thread pool of size 2. So 2 threads, this executor is going to use 2 threads to get the work done. So how do we submit tasks to this thread pool? Well, we could just, we can define a processor, okay, and it's going to be of type runnable. And what is this guy? Well, this guy is just a new instance of message processor, right? The class that we just created just a couple minutes ago. So we could just say that, the message is 2, all right? Or we can message is 3. Remember, this accepts an integer. So we can give it the particular message that this processor needs to process. And then we could just say executor dot execute, and then pass in the instance of message processor, which is this guy right here. So we're passing in the processor. All right, so similarly to this, I can define a couple of other tasks. So we've got one message with the number 2, we've got another message with number 3, and we've got another message with number 4, and we'll call it processor 1, well, this was processor 1, so let's change this to processor 2, and then processor 3, okay? And make sure you change the processors that are being submitted into that. So we're submitting these tasks. Again, I want you to think of this as a task because it implements the runnable interface. So we're submitting these tasks to the executor service, right? And the executor service is going to get the work done by involving the number of threads that we define in the pool, all right? So in this case, we only have 2 threads, and the work is going to be done. So let's run this example. I'm going to right click and go to Run As Java Application. And there you go. Notice it's saying pool 1, thread 1. So it received the particular message, and the message was number 2. And then the thread 2 in the same pool received message number 3. All right. So both of these were passed into the thread pool. And so the thread pool was done processing. All right. It finished message 2 and it finished message 3. And then finally, we have the 4th message here, or rather the message with number 4, right? This is the 3rd message. And the thread 1, which was done doing what it was doing before, the same thread is being used to process number 4. And then finally, it's done processing, all right? Now, you'll notice that this application is still running. Notice this red stop button. It's still, highlighted as red, meaning this application is still running. The reason for that is this executor service is still running. It's sitting there waiting to get more tasks to be submitted to it, right? And so we've only submitted this task, and this task, and we don't have any more tasks, but you can think of this as a service that is capable of receiving more tasks to it, and that could be done in other parts of the application. But for now, this application is pretty much done. We know that we've done with processing these messages, but it's going to continue to run because we haven't told this executor service to shut down, all right? So there's this method on this executor called shutdown, and this is what eventually makes this executor service gracefully shut down, all right? And what this does is, invoking this method rejects any new tasks from being submitted, okay? And gracefully shuts down the service. And I'm missing an extra L there in gracefully. Okay, that's what this guy does. So with that being said, let me close this manually. We're going to terminate this application so that it stops. And when I run it again, now you'll notice that this shutdown actually does gracefully cause the executor to shut down once the threads are done doing whatever it is that they're doing. So each of these processors, right, let's go to the message processor class. Notice that it sleeps for 3 seconds. So 2 threads are going to be working on processing these messages at the same time. So thread 1 is going to take one of these processors, and thread 2 is going to take the other one. And then once one of those threads become vacant, it's going to use that same thread to get the 3rd message processed. Okay, so this is also a way to recycle threads. That's what this is doing. It's basically, it spawns 2 threads and then recycles them. Once one thread is done doing what it's doing, it utilizes that same thread to do some other work. All right, so 2 threads are being used to process 3 messages here. Let me actually make another message. We'll call it processor 4, and we'll pass that processor 4 in here. All right, just so that we have slightly more tasks to get through. So 2 threads are going to work on 4 tasks, and 2 messages can be processed simultaneously because we've only got 2 threads. So once one of them becomes vacant, only then it will work on the 3rd message, and then finally the 4th one will get its turn to get processed by whatever thread is vacant in the thread pool. So let's run this again. Notice I've got the shutdown method on the executor. Let's hit run, and you'll notice that once we're done, this executor will gracefully terminate. And there you go. It's done processing message 4, and then you'll notice that the red button is no longer red because we eventually closed. Now another thing to point out here is if I print out the following text, we could say submitted all tasks. This is going to run immediately, okay? This is going to run immediately, meaning line by line these tasks are being submitted. Executor is also told to shut down so that it can gracefully terminate eventually when all the tasks are done processing, and then this gets printed immediately. Okay, so all of this instruction gets executed by the main thread, and the application will print this probably towards the beginning of the console. So it might be interleaved in one of these messages being printed out here, but you'll notice that it runs pretty much towards the beginning. So that shows that all of these lines get executed by the main thread. Executor is told to shut down eventually, right? That's what this shutdown does. And then this gets printed. So let's hit play again, and boom, notice that it's saying submitted all tasks. So this process of submission, right, is separate than the actual execution of those tasks. So this task is submitted, then this task submits, this one submits, and then executor is told to shut down when it's done, and then this gets printed to the screen. So that's why this gets printed first, and then when the 3 seconds are over, then you start seeing the messages being processed, as you can see down here. Okay, so just an important note to keep in mind. So while the executor is doing whatever it's supposed to do up here, while the tasks are being processed in the thread pool, we can have bigger and better code down here being processed, whatever it is. We can create new thread pools down here, what have you. All the code is going to continue to be processed by the main thread while these tasks are being executed using that thread pool, the pool of threads that are available. The executor service is going to be executing those threads. But what if you wanted to wait while the threads are being processed? You don't want to move forward in this application. There's a method that belongs to the executor class known as isTerminated. So you could actually create a while loop that goes like this. We could say while not executor dot isTerminated, while this is true, meaning the executor is not terminated, this loop is going to just hang in there and continue to iterate over itself. Okay, it's just going to do this. So this is essentially a never-ending loop if executor is never terminated. All right, so it's going to continue to run unless executor is terminated. So at this line, we tell executor to shut down. It doesn't do this immediately. It gracefully shuts down when the tasks are all done. And then this will become false, and so the while loop will end. But you'll notice that this submitted all tasks will run all the way at the end, not at the beginning, because the main thread is just going to hang in there while the threads are processing in the thread pool, doing their work, whatever it is that they're doing. So it's going to just wait inside of this loop until the executor is eventually terminated. And then you'll see that this gets printed. So this is going to print all the way to the bottom. Let's test this out. I'm going to right click and run as Java application. And so notice this time you don't see the submitted all tasks towards the top. You'll see that at the very end. And there we go. We see that all the way at the end. Now, if I didn't call this shutdown, let me comment that out. If I didn't call this shutdown method, I've commented out, this will never get printed. Right, this application will continue to run because this while loop, right? This while loop is just going to be stuck in here, and it's basically a never-ending, it's a infinite loop. So let's hit play, And you'll notice that once we're done processing all 4 messages, it's going to continue to keep the application running, right? Because Executor was never told to shut down. So Executor is still waiting to get more tasks submitted to it. Now, a quick note here, processor 3 was given the number 4 as a message, and processor 4 was also given a number 4. So that's why I have some repeat messages here, but hopefully you get the idea. It doesn't matter, it could be any number, of course, right? Whatever the message is. So it's never a good idea to not have this Executor shut down. You want to make sure you always have this, because your application will run, frankly, forever, and it's going to use up resources. So let's just close this, and I'm going to uncomment out that. This is important to have. Another variation to this shutdown method is shutdown now, and that basically does exactly what it sounds like. It shuts down the Executor immediately. It's called shutdown now, like that. And this is going to terminate the Executor service immediately, okay? So hover your mouse on this method definition just to get a better idea as to what this does. Notice it says, attempts to stop all actively executing tasks, halts the processing of waiting tasks, and returns a list of the tasks that were awaiting execution. So this is basically a termination. It doesn't matter where the thread is in there. If it's doing work, it's going to be told to terminate. And you'll notice that, let's hover our mouse on this again. It's saying this method does not wait for actively executing tasks to terminate. All right, there's another variation to this. You could say await termination if you want a slightly more graceful way to terminate. This one shuts tasks. It doesn't matter where they are in the process, is going to shut them down. So let's hit play, and you'll notice that, of course, once this was told to gracefully shut down, it didn't even get a chance to process the rest, because then we told it immediately to shut down, and that's why we don't see message 4 anywhere in here. Okay, message 4 didn't get processed. And notice that we had problems. It's saying unable to process message 2 and unable to process message 3 because there was an issue while the processing was going on. Okay, so I typically don't like this shutdown now. You don't need to use that, but it's there for you in case you ever need it. This is one way of making the main thread wait in this loop until the Executor has gracefully shut down. There's another way to do that, and that is known as await termination. Right, that's a method that I showed you just a little while ago, and that is, it basically goes like this. You can do Executor dot await termination, and we give it the timeout. So we could say within 10 seconds, and that comes from the time unit class, and we could just choose the static variable in there known as seconds. I think this is an enumeration, but let's just click in there, and you'll notice that this is actually it's an enumeration. So then an enum is just basically a data structure that contains a list of strings that can be used. Not important to go over that just now. We may cover that later on, but you can look up on your own about what an enum is. It's not very difficult to understand. It's a container of variables, and you can give a constructor to an enum. But anyway, you have options for seconds, nanoseconds, milliseconds, minutes, hours. So we can give it 10 seconds here. It asks for a try catch. So let's just use that option because we can run into the interrupted exception. So what this await termination is going to do is it's going to wait only 10 seconds before moving on to the next line. All right, so we told this to shut down, but this guy is going to wait only 10 seconds before it moves to the next line. So instead of having that while loop, we can basically choose to give a particular time, 20 seconds or 30 seconds or 20 minutes, however long you want to wait before moving to the next line. So you'll notice in this situation, again, submitted all tasks is going to run all the way to the end. So let's hit play. And you'll notice the messages are being processed, and only at the end are we going to see all tasks submitted, like that. Now, if I told this to wait only 2 seconds, right? If I told this to wait only 2 seconds, then this is going to wait only 2 seconds before moving on to bigger and better code that we have down here. So let's hit play. and boom, there you go. You notice submitted all tasks was played pretty much towards the top right after 2 seconds. So this waited only 2 seconds to move on to the next line of code, whatever it is that we have to get done.